All right, everyone, let's go ahead and get started. I want to welcome everyone to this Excel webinar on charting, what-if analysis, curve fitting, and solver. It is co-hosted by Experts Exchange and Brad Yundt, who is one of our top experts on Experts Exchange. I am Jen Prentice with Experts Exchange, and like I said, I want to personally thank all of you for attending this webinar. A few housekeeping items worth noting before we get started. First, take a look at the right side of your screen. You should see a chat window. This is where you can ask questions that you might have about the webinar software or about Brad's presentation in general. So just type your question into the message box. It will be sent directly to myself and Brad. And if we have time at the end, Brad will answer some of your questions. If not, Brad and I will personally follow up with all of you after the webinar and make sure that you get an answer to your question. Second, in the chat window, you should see links to download the .xls and .xlsm versions of the Excel workbook that Brad will be using in his presentation today. You should have received those files via email earlier this week, but just in case, wanted to send them to you to download again. A few of you emailed me and said you're having trouble downloading the .xlsm version of the webinar. If that's the case for you today, don't worry. We can email you a copy of the workbook after the webinar, and you will still be able to follow along with what Brad is doing today. So don't worry about that. And then third, if any of you have to leave the webinar early, we are recording Brad's presentation, and we're going to make it available for everyone sometime by Monday. And Brad is actually giving another webinar, this one on VBA, at this time next week, so I'll also be sending you the invitation to that webinar on Monday as well. So many of you are already familiar with Experts Exchange. For those of you who are not, we are a technology help website where individuals and businesses go to find answers to their technology questions. We have nearly 3 million solutions in our knowledge base, covering a wide range of technology topics from Excel and VBA to SQL Server, solutions about Microsoft products, Apple products, etc. There's a good chance your question has already been asked by someone else, but if you don't see the answer you need, you can ask a question on your own or collaborate with one of the thousands of experts, guys just like Brad, including hundreds of Microsoft MVPs on Experts Exchange. So as I said, Brad is one of our top experts on Experts Exchange. He is also a Microsoft MVP. Brad has been working with Excel since 1988, and in 1995, he discovered Excel's then brand new Visual Basic for Applications feature, and he took advantage of the program to help him with some of his engineering work, and he still uses that program today, actually. He now uses Excel and VBA for all of his routine engineering calculations and tasks, actually. So in 2003, Brad joined Experts Exchange, and he said that his skills took a quantum leap by collaborating with the experts in our community. He has since answered over 9,000 questions on the site for people from all walks of life, and he currently serves as a zone advisor for Microsoft Office and Excel. 4 years ago, Microsoft took notice of his service, and since then, every year since then, they have honored him with their Most Valuable Professional Award for Excel. When he's not answering questions on Experts Exchange, Brad is a mechanical engineer at Applied Research Associates. It's a research and engineering company that provides a broad range of technical expertise in defense technologies, civil engineering, and a number of other fields. So if you are interested in learning more about Applied Research Associates, you can visit their website, or you can, which is up on the PowerPoint right now, or you can email Brad. I think now it is time for me to pass the presenter ball over to Brad. I know that you all have been anxiously waiting to hear his presentation, so without further ado, here is Brad Yundt.
Okay, so you can see my screen now?
Everyone should be able to see your screen in just a minute, Brad. Yes.
Okay.
Can see your screen.
Okay, I'd like to start off with a self-test on Excel knowledge. And this test was originally developed by Aaron Blood, and I've made small adaptations to it, mostly adding cute pictures to it. And the proficiency is divided into a number of categories. I'm hoping that most of the people that are listening to me are in what I would call the intermediate or advanced category. And what that means is that you're comfortable building formulas to manipulate text and dates. You know what a pivot table is, you know what an add-in is, you know how to record a macro and use it later, and you're comfortable using functions like VLOOKUP and choose and mid, COUNTIF, SUMIF, things like that. So that would be with the I Love Spreadsheets coffee mug here. If you are the kind of person that thinks that the Clippy is real cute, then you're probably a novice type of a user, and you'll find that I'm going pretty fast in this presentation. If you can hang on, my best wishes to you. But I'm really aiming this presentation at people in the intermediate to advanced categories. When I say advanced, what I mean is that you're very comfortable helping other people to use Excel and helping to debug their spreadsheets. You're comfortable recording macros and modifying them. And when you write formulas, it would include things like sum product, indirect, index, match, and offset. The last two categories would be for people that you see posting in web forums like Experts Exchange, the Microsoft news groups, and these are people that really do know the product backwards, forwards, inside and out, and so on and so forth. Okay, the first thing that I want to talk about is charting, and this would be on the charting and curve fitting worksheet that I've gone to. The workbook that I'm showing here, it has been originally developed in Excel 2003. I tried to go through it and modify all of the instructions to reflect how you do it in Excel 2010. There are a number that I missed, and I'll talk about those as I go over things. So I am presenting using Excel 2010 here. The exact same workbook will show up as a .xls for 2003 users, and if you're unable to download the .xls-m and you want to use a sample workbook, you can use the .xls as well. I know that a number of my government customers are unable to receive .xls-m workbooks in email because it gets cut off at the pass. But the .xls will go right on through. So the first type of a problem that I want to talk about is plotting the pressure accumulation before an explosion. So what I'm showing in this little picture here is a cartridge that contains a fluid, and then as you heat that fluid up, it increases in pressure on the inside, and ultimately the cartridge will rupture. So what I've done is I've generated some data over here in the gray area, and this tracks the time versus pressure inside the test cylinder. And I'm plotting that data in this chart over here, and what you'll see is at the very end there's what was called an explosion, and that's when you get the actual rupture in the test container here. The calculated burst pressure for this is shown by this line right here, and the actual accumulation of pressure over time is shown here. So what this data is saying is that you're able to exceed the calculated burst pressure by just a little bit before it actually let loose. Now, one thing to note is that this line right here, actually there's no supporting data for it. You can't see it anywhere on the worksheet. Actually, what I did is I created a named formula. So if you go into the name manager and you go into, the first one is called burst pressure, what you'll see is that there is a fairly long formula like this, and that is the refers to formula. And what it does is it returns a series of values. And those are the values that the chart is plotting. Now I've reproduced this formula in simplified form over here in the text box. And what you'll see is that I'm taking the row function, and when I give it a range of cell addresses, it returns the row number for each of those cell addresses. So in this case, it'd be the numbers 2 through 16, because you're referring to cell A2 to A16. When I divide that by row of A2 to A16, what I'm really getting is 15 ones. So I'm taking that array of 15 ones and I'm multiplying it by 110,000. And what that really means is that I've got 15 instances of the same value, which is 110,000. That's what I'm plotting. So if you look at it, you can see that there's quite a few data points here. I've turned the markers off, so you don't see the individual markers, but you do see the data points when you select the line. And that's how it's being done. Now, if you wanted to add that to the chart, I'll take it out just to so you can see it from the start. What you would do is right-click. Let's see. Okay, I'll take the series here and I'll select data, and then I want to add a series. And what I want to do is I want to add the series for the burst pressure named formula. And the way that I'll do that is I'll say equals, and then the name of the workbook inside single quotes, sample workbook. And in this case, it's a .xlsm, and then single quote, and then an exclamation point, and then burst pressure. And it should take that formula. Yes, it does. And then I'm going to select the X values, which is going to be the time. And then I'll click OK. And then if I wanted to format that, I can format the data series. And then I can choose the line color if I want. Bring back a nice red, and I can choose the line style. I can make it a little fatter, and I can change to the dash type. Now the line that was up there originally was using a pattern, and I did that in Excel 2003. So that's why it looks a little different than it did before. Okay, the next thing that I want to show you is that you can get the equation of this curve fit to the data down here. And what I've done is I've put a trend line in the, let's see. Okay, so I've deleted my trend line. Now I select one of my data points, any of them, and I can add a trend line. Then I get a dialog that asks me what type I want. And in this case, I know that I want a third order polynomial, so I choose that. And I can choose to display the equation on the chart there. And then if I wanted to, I can right-click it and I can format the label, and I can go to the number, format type, and I can increase the number of decimal places so I can see more of them. And I can take this and I can move it up a little higher so I can actually read it. So that's how I produce the trend line. Now another way of getting at that exact same relationship is I can take the data and I can use the linest function. And the linest function does a regression analysis and return the least squares fit to your variables. So in this case, I'm going to have three variables, which I'm going to call time, and the square of time, and the cube of time. So those would be my three x variables. And the y variable is going to be the pressure. So linest is expecting to receive as its inputs the y values, which will be here, and then the x values, which will be there, and then there's two constants, which I always default to true and true. The first constant is whether or not you want to force the coefficient to be 0, and I don't want to do that, so I say true for that. And the third parameter is, the fourth parameter rather, is whether I want to have the statistical functions returned, and I always want to see those as well. So what I've got right here is the result of the linest function, and you can see that I'm entering it. I'm selecting D21 to 25, which would be these cells here, and then I'm selecting as the next parameter this block of cells here, and then it's true and true. And then what I do is I array enter this formula, and to do that you hold the Control and Shift keys down, and then you hit enter, and you'll notice that Excel added the curly braces before and after that formula. So what I've got is a formula that's in a 5-row by as many as the coefficients that you need are for columns. So the constant term would be right here, and then the time term and the time squared term and then the time cubed coefficient would go there. The other thing that's of particular interest is the r squared value, which speaks to the quality of the correlation. The r squared value is going to vary between -1 and +1. And a +1 means that the correlation perfectly explains the experimental data. So in this case, I've got very, very close to 1 for the r squared value. So I feel pretty comfortable that my cubic formula, shown by these coefficients or by this equation up here, does a very, very good job of explaining the data. Now I could have also created this exact same formula using just time as the variable and then calculating the time squared and the time cubed terms on the fly. So let's see how I did that. What I did is that once again I've got D21, D35, these cells here, the same Y values, but now I've got just A21 to A35, the time values, and I'm exponentiating rather to an array constant. And this array constant is 1, 2, and 3. So I'm exponentiating to the first power, which is the actual time values, to the second power, which is time squared, and to the third power, which is time cubed. So it's a little more compact way of writing the formula, and it also allows me to not necessarily reproduce the extra 2 columns of x values here. And you'll notice that I omitted the third parameter, and that's because it defaults to true, which is what I want. So, that's what I did there. Now, the next thing that I wanted to show you was dynamic charting, and what I want you to see is that the chart will automatically expand or contract as the amount of data changes. For example, if I would add a data point here for time 12, and let's say it has a value of 130, okay, you see that it was automatically added to the chart. Now, how did I do that? Well, if you click on one of the data points, you'll see that I've got 2 parameters up here. One is sample workbook X data, and the other is sample workbook Y data. Now, where do those come from? Well, if you use the name manager, we're going to look for X data, and we'll see that it has this formula here, and I'm reproducing it down here in shorter form without the worksheet names. And it's a range that starts in cell A45, and then it continues through a cell that contains the last piece of data. And the way that I find that cell that contains the last piece of data is I use the index function. So I pass the index function this entire range here, and I say count up the number of cells that actually contain data. And that, of course, then gives me the index number of the last piece of data, which is cell A56. And then I do the same thing for the Y data over here. And to plot it, we will go into select data, and we've got series 1, and we'll edit it. And what you can see is that I've got, for the X values, it would be equal single tick sample workbook.xlsm, which is the name of the workbook, single tick exclamation mark X data. You'd like to think that you could put in just the X data, but Excel does not take that. You need to actually have either a worksheet name or the entire workbook name inside these single quotes and followed by the exclamation mark. Likewise with the Y values, I put in the same type of a formula and then returning the Y data. So that's how I did that. Now the next thing that I want to point out to you is that there is a gap in the data, and if you look at the source, the value is actually blank in that cell there. And I have chosen not to bridge the gap across the, from these 4 points here to these points over here. But that's actually a choice that I can make. If I would like to override that choice, what I can do, and here I'm down on step 6, is I can right-click a point, I can go to select data, and I can click this hidden and empty cells, and I have a choice of showing empty cells as gaps, which I've done. I can show them as 0, or I can connect the data points with a line. So if I do that, then you'll see that the line actually goes right on through. Now, another thing that you'll notice that I did is the formatting on the y-axis does not include the decimal point. And what I did there, if you format the axis, go into the number, I could have had it linked to the source, in which case the decimal point appears, but that doesn't present very well. So what I like to do instead is to choose the number of decimal places myself. So I override the formatting that I used on these cells here and specify 0 decimal places. So that's what I did with that. Next thing that I wanted to show you is the chart title. It actually comes from this cell right here. And as I change the value of that and make the title bigger, you can see that it actually picked up the text that I added in this cell. And what this actually is not the chart title feature, but it's actually a text box. And I inserted a text box into the chart. And you can do that by selecting chart, insert text box, draw a text box, and equals that cell. And there it is again. And then from there, what I did is I just formatted it. So I get the yeah, formatted it. I can make it bigger, and I can position it where I want. So that's how I created the title for the chart. And the last thing that I did is I show one point where I wanted to have the value displayed by it. And the way that I did that is I left-click that point twice, and then I right-click that point, and then I added a data label. And you can format that data label, and you can have it show the series name if you'd like, the X value, the Y value, or just the Y value. So that's how you add a number to the chart if you want to. Okay, now the next thing that I want to show you is how you can change the chart by using a drop-down. So in this case, I've got a data validation drop-down in cell B82, and as I select different values in that drop-down, you can see the chart on the right changing. Now let's see what's changing. It's actually, I'm changing the y-axis, I'm changing the data being plotted, and you can see that the formatting is even changing on the y-axis. So let's dig into that a little bit. If you select this column of data here, what you'll see is that there's actually a formula in cells B83 to B96. And this formula is returning the £NA error value in these blank cells at the bottom, and it's returning a value from the source data over here in the rows above that. So let's look at one of those formulas. It's an index and match formula, and the way that it works is you look at the same row, and what you're doing is you're asking the question, is this title here, which column does that refer to over here? And in this case, temp matches the second column, so the match function is going to return 2 as its answer. And then the index is going to refer to this entire row, and you want to return from the first row and the second column of that range. So what you're going to return with this formula is the 310. Now, what you've got is index and match here and index and match there. So what you're doing is you're testing, in this case, whether index and match returns an empty string, which is double quote, and if that's the case, then you return the £NA error value. And if that's not the case, then you return the actual value from this chart right here. Now, if I didn't do that, if I just said it equals index of this range and then match, what would actually happen is it would return a 0 over here, and I don't want to see that. Now, the next thing that I did is, if I pick this, I can see that I'm plotting XX data and YY data. So it's more named ranges. So let's see what I did with that. So I go into the formulas name manager, and I'm looking for XX data, and you can see that that's a fixed range between A83 and A96. And YY data is using one of those, starting with a fixed point and then going to an index function using count A to return the last piece of data that actually occurs in this chart. So that's why I'm seeing the points that I'm seeing, is that I'm limiting the range to what's shown here. Now, why don't you see the £NA error value in these cells? Well, what I've done is I've used conditional formatting in this entire column, and I'm hiding the £NA error value by making the font color the same as the gray background color. So on the home menu, I go to conditional formatting, manage rules, and you can see that what I've done is, if it's an error, then I format, and on the font, I've chosen the color that's the same as the background color. So that's what I've done. Now, the next thing that is somewhat interesting is that the formatting, the number of formats here, change automatically with the data. And if you look at the formatting that I chose, it's a custom format. And I'm using this format string here. And if the value is less than 1.5, which is going to cover the entire percent range, then I want to show percents with 1 decimal place. If it's less than 500, then I want to show the actual number with a single decimal place. And if it's over 500, then I just want to show the number with no decimal places. And the @ sign means that the text is displayed as well. So that's the formatting that I'm using for this column right here. Now, the chart doesn't show that decimal place, although the source data does. So if I format the axis and go into number, you'll see that I'm using another format code. And in this case, if it's equal to 0, then I display the value 0. If it's less than 1.5, then I assume it's going to be 0. It's going to be a percentage number with no decimal places. And otherwise, I display the number with no decimal places. And that's the format specification that I chose for the y-axis of this chart. So when I change this to yield, I get percent. And the point that 0 is overlapping, and I could have made that B percent, but then it would have messed up when you want to use, one of these sets, like these numbers here. Here I want it to actually be 0. So I had a choice of having this value be 0%, which would look stupid here, or having it look still somewhat stupid, but not quite as bad when I've got the yield condition here. So I'm showing 0 rather than 0% like I'd really like to have. So that was the best compromise that I could make in this particular situation. Now, another thing that you may notice is that the grid lines are actually white. And what I did there is format the grid lines, and I'm showing a solid line, and I can pick the color, and I can make it white, and then I can change the line style, and I can make it a little bit fatter, or I can make it real skinny. And what I found gave good appearance to my taste is to make it the 2-point wide. And I did the same thing for the vertical lines. And to me, not having bold black grid lines make this chart look more subtle, and I can concentrate more on the meaning of the data itself. And if I want to get the exact value, the grid lines are there, and I can figure it out. But I don't have big, bold, black grid lines that draw attention to themselves. Okay. Now, the next thing that I wanted to show you is a feature that exists in Excel 2007 and later. And that feature is that if you wanted to add data to a chart, and the data comes from what's called a table, then the chart will automatically expand to receive the new data. So if I create a new column, and I put in some data, let's say it's You can see that the points for value 9 were added right here. And I still got the 5 rounds. And if I added a round 6, and ignore that message for the moment, let's go up to 450. And you can see that it's adding this new series to the chart as well. So how did I do that? If the chart already exists, then what you can do is you can click on any data point in the source range, and then you can use the insert command, and I want to insert a table. So right now it's grayed out because I've already done that. But had I not had a table as a source, if it's just a fixed reference to these cells, then I could have made those cells a table, and then they would automatically expand and contract according to the amount of data that actually appeared in that table. You can also set up the cells as a table ahead of time, and the way you do that is you select them, and then you open up the insert table menu, and you can say that that's a table. So if I would have gone up to, let's say, here, the insert table menu says that I can make this a table right now, and then it would automatically, the plot would automatically grow and shrink according to the number of rows that were in this table. So that's a very nice feature that Excel 2007 and later has. Next thing that I want to show you is using goal seek. And here I've got a little profit and loss calculation for a potential sale. So what I might want to do is I might want to get the value in my gross margin percentage to be equal to 50%. And what I'm going to do is I'm going to change the value in cell C10 until I get that 50% value. So what I'll do is I'll go into the data menu, what if analysis, goal seek. I'm looking to set cell F14 to a value of 50% by changing this cell here, and let's see what happens. Okay. So Excel found that if I made the profit 13.3%, then I get my 50% gross margin, which is what I was looking to do. Another type of what-if analysis that you can do is going back to curve fitting. And if you want to fit data to something like a sine wave, you'll find that LinEst really isn't set up for that kind of problem at all. So, and neither is the curve fitting or trend lines in charts. But what you can do is you can use Solver, which is an optional install, to help you do this. So what I've done is I've shown an equation over here where I've got speed is a constant times the sine of another constant times the delta t plus a third constant. So I've got 3 adjustable constants and the variable delta t, and that gives me the result of speed. So I've got some raw data over here where I have different values of delta t, and then I got the actual measured speed over here, and I've got a prediction. And the prediction is made using this formula here, using these 3 assumed coefficient values. So what you'll see is it's equal to G46, which is this coefficient here, times the sine of parenthesis, the second coefficient times the delta t, plus the third coefficient, close parenthesis. So that's the calculation that I'm making. And you compare that prediction, and you can see that it doesn't even come close to the actual speed. So the difference between the actual speed and the prediction is what I call the deviation. So this is just, one cell minus the other cell. And what I want to do is I want to drive these deviations as close as I can get them to 0. And more particularly, I want to square deviations, because this is going to be a least squares analysis. And I want to drive the sum of the least squares equal to 0, if I can get it. So here I have the sum of the squares, the sum square function, which is acting on this range of cells here, and I'm adding it up, and this is the value that I want to minimize. So to do that, I'm going to open Solver, and I want to take the objective cell, which is the sum of squares, D60, and I want to make that to be a minimum value. And I want to do that by changing these 3 cells here, which would be the changing variable cells. And let's see what happens. We'll try solving it. Didn't like that. Okay. The objective cell is this. So I got 1 objective, got 3 changing cells. I'll click Solve again. Okay, so it offers me the choice of keeping the solver solution or restoring the original values. In this case, the sum of the squares have been reduced greatly, so I think I'll keep the solver solution, so I'll click OK. I'm going to close this, and what you can see is that I'm plotting now the predicted values and the original values, and you can see that the predictions lie right on top of the original data. So that's a good cross-check to make sure that the correlation really does fit the data. Now another way that I can use Solver is, this is for people that do accounting. You may get a check in the mail, and you know that this particular customer has a number of outstanding invoices, and the question is, this check, what invoices are they really paying on? So if you've got this list of invoices here, which are due on various dates, and you get this check in here, what's the customer really paying? So what I've done is I have added up the product of the amount on the invoice and a control number here. And I'm defaulting the control numbers to be a half. And that's kind of an arbitrary number. Just don't use 0 for the arbitrary number. So I'm going to take the product of the amount times the proportion paid on this check, and I'm going to add that up. And I'll do that using the sum product function. So I'm taking the product of this column times this column, and then add up the results on a row-by-row basis. And that's what appears here. So what I'd like is for that to equal this figure here. So the way I'm going to do that is I'm going to open Solver, and what I want is my objective cell, which is going to be this one here. I want that to equal a value of 1194. And I'm going to change these cells here. And I want to have a constraint because I'd like these cells to be either 0 or 1. 0 means that that invoice wasn't being paid with this check. 1 means that yes, it was. So I'll add a constraint, and the constraint is going to be that this column of cells here is going to be a binary constraint, which means it's either 0 or 1. And then the next thing that I want to do is I want to look at the options, and I want to uncheck the ignore integer constraints. And this is something that does not appear in this instructions here right now because I didn't need to do that in Excel 2003. but I do need to do it in Excel 2007 and 2010. All right, so now I'm going to click the Solve button, and I think it takes about 30 seconds or so for Solver to look through all of the possibilities and see what the answer is going to be. And what Solver is going to do, I think, is find 4 checks that add up to that figure right there. You can see it's going through its efforts down here. Okay, so Solver found this check, this invoice, this invoice, this invoice, and this invoice. Those 4 numbers add up to $11.94. Am I happy with that? Yes, I am. So I'll accept the Solver's answer, and I'll credit those invoices as being paid. Now, I mentioned before that Solver is probably not installed on your version of Excel. So I've given instructions for how to do that. And there are 2 parts to the instructions. The first part is to make sure that the code for Solver is actually installed on your hard drive. And the second part to the instructions is to make sure that Solver add-in is being loaded. So for the first part, if you want to see whether the Solver add-in is loaded and you want to make sure that it's going to be active, then what I'm going to do is I'm going to go into File Options and then go into Add-ins. And I can see that in my case, Solver add-in shows right here. But if it had shown right down here, what I would do is I would click the Go button, and then I would make sure to check the box for Solver. Click OK, and now, since Solver was already installed on my hard drive, I can now use it. Now, if Solver did not appear in that dialog, then what I would do is go into the Add Remove Programs control panel. And what I'm going to want to do is to change or remove programs once I've chosen my copy of Office, and the list populates. Okay, so there it is. In this case, I'm going to look at Office 2010. I'm going to want to click the Change button. It's going to give me this dialog here, and I want to add or remove features. I go into Excel, I go into Add-ins, and I see Solver right here. And I've got a choice of Run from my computer, which means that it's installed already. Installed on first use, which means that it will ask me for the CD-ROM as soon as I need to use Solver, or not available, which I believe is the default condition. So what you want to do is you want to change from not available to run on my computer, and once you've done that, then you'll be able to go back and go to the first set of instructions. Okay, next thing that I want to show you is data tables. And here, again, I've got a profit and loss type of a situation, and I want to explore what happens as I change the profit percentage. Well, you can say, okay, what if profit's 2%? What if profit's 3%? What if profit's 4%? And you can plug in the value here, and then you can print it out, and you can tabulate the results. But an even cuter way of doing it is what's called a data table. So what you'll do is you will have a set of values for different profit percentages. You list them in a column here. And then in my case, I want to return the selling price, and I want to return the gross margin. Those are the two parameters that I want to be paying particular attention to. So what I'll do is I'll just say this cell here equals F11, which is this cell, and this cell here equals F14, which is this cell here. And then I select the grid containing my column values and these formulas that I just talked about. I'll go into the data menu and what if analysis, and I'll choose data table. And in my case, the inputs are in a column, and I want to plug them into this cell here. Click OK, and there's my answers. Pretty painless. Now, if you look at one cell in this range, you'll see it has this funny-looking formula, which is an array formula because of the curly braces, equals table left parent, comma, C10 right parent. And if I tried deleting that value, it would tell me I can't change part of a data table. I can delete the entire range that contains that array formula, but I can't delete one value. So that's a way of protecting your data table. Now, you can also have what are called two-value or two-input data tables. So here, let's suppose that I wanted to vary the labor hours, which shows up here, as well as the profit percentage. And I want to look at just the gross margin as the output. So what I'll do is I'll list the labor hours in a row across the top here, and the profit percentages in the column down here. And then I'll put the formula for what I want to return at the intersection of those two. In this case, it's going to be equal to this cell here. So then I select the rectangular range containing that little formula, and the row inputs and the column inputs. I go into data, what if analysis, data table, and the row input cell, which would be these values here, they're going to go there, and the column input cell, which is these inputs here, is going to go there, and then I'll click OK, and there's my report. So that's pretty good. Now what if I wanted more than that? What if I wanted 3 inputs or 4 inputs? Well, the fact of the matter is that Microsoft does not give you that capability right out of the box. You have to do a little bit of creative thinking. So I'll show that in this worksheet over here. And what I'm going to do is I'm going to have 5 different inputs that I'm going to have varied across this entire range here. And the way that I do that is I actually set it up as a modified single input data table. And I'm going to have the single input is going to be what I call the index value, which in my case is just going to be the numbers 1 through 25. And depending upon the index value, which I'm going to return to this cell here, my worksheet is going to retrieve values from this range using an index function that's based on the value that's here and maybe a little bit of calculation. So this happens to be an engineering problem, and I happen to be a heat transfer engineer. So what we're actually doing is I'm heating a fluid up in what I call a double pipe heat exchanger. So let's say that you have a hot fluid in this side here and a cold fluid over here. And what you want to do is you want to heat the cold fluid up, and you want to cool the hot fluid down to this temperature here. And heat will always transfer from the hot stuff to the cold stuff, and you need to have surface area in order to make that happen. Now, if you were a cat and you wanted to reduce the amount of heat loss because it's cold outside, what do? You curl up into a ball. You reduce your exposed surface area. And if you're that very same cat on a hot summer day and you want to maximize your heat loss to the environment because you're just too darn hot, what do? You stretch out as much as possible. So you've increased your surface area. So what the cat knows how to do instinctively, the engineer has to do by a pretty laborious calculation. So what we're doing is doing the calculation in this part of the spreadsheet here. And then here is a practical heat exchanger that could be built using this calculation method. Now, the color coding that you see over here occurs because when you have a fluid flowing through a pipe, it can either be flowing in what I call a turbulent regime, which is very chaotic but has very, very good heat transfer, or in what I call a laminar regime, which is very smooth, very orderly, no ripples, but it has absolutely miserable heat transfer characteristics. So if your heat exchanger was entirely in the laminar regime, it would be very large. If your heat exchanger was entirely in the turbulent regime, it would be fairly small. Now, in this particular case, part of the heat exchanger is going to be laminar and part of it is going to be turbulent. And as you're heating the fluids up, the hotter you get, the closer you get to this turbulent region. So what I'm doing is I'm taking my heat exchanger and I'm breaking it up into 25 different slices. And you can see a bunch of different tubes here. You can consider those to be slices of this one very long heat exchanger. So what I'm doing is I've got a figure of merit over here which says over surface, and what I'd like to do is to have that value be close to 0. Right now what it's saying is that the size of the heat exchanger that I've chosen, 104 square feet, is nowhere near big enough. It needs to be much larger before we can do the job that needs to be done. So what I'll do is I'll increase the number of heat exchanger pieces that are acting in series. And I'll do that using this control here. And you can see the value of the oversurface is decreasing as I keep increasing this thing. And I think you can see that if you were doing this by trial and error, that would be an awful lot of calculation that Excel is doing very, very quickly for you right now. And there we have it. 180 of these pieces, each one 20 feet long, will exactly do the job that needs to be done.
Brad, I'm going to...
So, at this point...
Brad, I'm going to interrupt you just a minute just to let everyone know that if they have to leave because we had said that we are going to end at noon, that is totally fine. We will record the rest of it and send it out via the recording link later next week. But otherwise, stick around and Brad's going to wrap up.
Okay, so I'm done with the formal part of my presentation. Let's see if there's any questions that I can speak to.
Actually, I think that we have captured all the questions via the chat functionality, and since it is nearing the noon hour, we are going to go ahead and wrap up here, and I will send all of your questions out to Brad, and what will happen then is that Brad will answer all of your questions, and I will send them back to all of you when I send out the recording. So thank you guys so much for attending today. We really appreciate it. And if you want to contact Brad personally, like I said, if you want to learn more about where he works, then you can contact him via this email address, and you can contact me if you have any questions about Experts Exchange. I am happy to tell you all that you need to know about the site. So thank you guys again, and have a great day.